Welcome back to the channel. Today we are going to understand a very fascinating subject, a very fascinating data structure, which is Bloom filter. Once you understand this, you will really love the concept and sure you will be using it in your application as well. This Bloom filter is being used by various companies like Google, Amazon, Netflix, Cassandra, Redis. So let's start. And by the end of this video, we would understand what is a Bloom filter, why do we need it, how does it work internally, and the concept of false positives and how do we implement it in Spring Boot using Guava library. Say I have like millions of customer IDs. Now whenever I do a request, say out of those, say I make 1 million requests. Out of those 1 million, say 10% are invalid or 20% are invalid. So in that way, we are actually still hitting the database, even for those invalid entries. So this is where Bloom filter will come into picture and it will help us. Let's understand how Bloom filter will help us. Bloom filter is a probabilistic data structure. Just keep this in mind. It is space efficient, probabilistic. So what it does is it will either return definitely not or possibly maybe present. So possibly present or definitely present. That is why it is called as probabilistic data structure. Now let's understand with the example. Let's take the example of customer ID. The customer ID is 100. My hash function 1, hash function 2, hash function 3. See my bit array size is 16. Okay. Initially, all these would be it is zeros. Now say for 100 my hash function returns 1, 4 and 7. So what I will do is I am setting this 1. This will also be set to 1 and 7 also set to 1. Okay, now I insert HF customer ID 101. So I get 8, 10 and 1. What will happen in the third stage when we are inserting for 100, 101? See 1 is already set to 1. So it will be as it is. No change here. 8 and 10 are not set. So I will set 8 and 1 here. Okay. Now what happens? Say I want to do get customer ID 100 100. So what it will happen basically? We'll first call the Bloom filter. Now Bloom filter will get the hash values. So basically it will run the hash functions and it will return these three values 1, 4 and 7. And when it looks at the status of the bit array here, 1 is set to 1, here bit is 1, for 4 it is set to 1 and for 7 it is set to 1. So it is getting 3 ones. So what it will return is maybe present. See I told you it is probabilistic, that is why it says maybe present. And say I run for an invalid customer, say 999, and let's take the example here and say it returns 1, 12 and 10. Let's take this one. See 1 is already set to 1, 12 is 0 and 10 is 1. Now what will be the answer? Answer, it will be definitely not present. Why definitely not present? Because what it says is this bit 12, right? Bit 12 was 0. So any bit when it returns as 0, it is very sure that this customer ID is not present. Now, what will happen in our case when we are sending invalid data? So, invalid data when we are sending, so it will get this 0 and it will never hit the database. It will directly return the data is not present or customer ID is not present. Now, let's take one more example. Say customer 110. Okay, let's assume that hash function is 1 is 10 and say for 101 it is 8. Let's take it. Now it returns 1. It also returns 1. It also returns 1. As you can see, in this case, every bit is set as 1. Now what will happen in this case? Even though customer is not present, it will say may be present. Now this will go to database. So this is the case, right? And this is what we are saying as false positive. So there are chances that some invalid entries may be returned as may be present or possibly present, and then they might hit the cache or database layer, whatever we have. But in case of valid customers, right, it will always return may be present. But in case of invalid, it may return may be present, and most of the times it will return definitely not present. So say I have 1000 entries, and there are chances of 1%. You could say 1% failure or false positive. So when we say 1% false positive, out of 1000, when I make 1000 invalid request, so what is the 1%? 1% is 10 basically. So 10 requests may be returned as it's present. This 990 will be avoided or discarded and returned as definitely not present. This is the advantage that we get. So we are not hitting the database for most of the invalid requests. We are only hitting the database or the caching layer for the valid request. Yeah, there could be cases like I told you about 110, but that percentage will be very less. Still, we are saving a lot of calls from hitting the database. Now, this number, when it is in millions, it gives a lot of advantages. So this is the introduction to the or the what is a Bloomfield. So before we move to Spring Boot application, I'll just give you the background here. Say my table is customer. I'm storing the customer ID and the name of the customer. For now, I've just taken 3 customers, and these are my 3 customers. Now let's look at the Spring Boot application. So here I'm just connecting to my Postgre database, and let's look at the configuration first. So this is the configuration for your Bloom filter. One more thing, I'm using this library of Google, basically Guava library for Bloom filters. Just keep this in mind. This is the dependency which is required. This dependency is for the Postgre. Rest all is for the Spring Boot. Now what happens here, when I create this bean of Bloom filter of long, so if you look at my model, right, now this is my customer entity, the customer table that we have seen. So this ID is long and name is string, but my ID, this is the important ID which I'm going to use in my Bloom filter. So this Bloom filter, that is why it has been set as long, Bloom filter of long. So the first parameter based on your ID, whether it's long or a string, you will call the different methods. Now in this case of it is long, that is why we are calling funnels.longfunnel. Basically this method will actually convert it into bytes. So we don't have to do anything. It's just a parameter that we are passing to this Bloom filter create static method. Okay, and expected insertions. So this is we are saying Bloom filter that okay, I'm expecting 10 million records. or 10 million customers. See, this number is very important. See, if this number is very small, so what will happen if your array size is smaller, right? Then every bit would be set as 1. And then we would end up getting maybe present. And this is not the objective that we are looking for. So that is why you should give the correct number here or your approximate number. So if it is 10 million, 100 million, 1 million, whatever. And then this is false positive percentage. What I told you about this 1%, right? So what is your expected false positive that you are looking for? So say I am making 1000 requests, then I want say 990 should be discarded or shouldn't hit the database. That means 1% is okay. 1% is okay for me. That is I am setting this. Based on this, so this it is Guava library, right? So Guava library will create the hash functions, number of hash functions, etc. You don't have to worry about this. The array size, bit array size, or the hash functions. Everything is taken care by the Guava library. You just call this bean, and then you are ready to use it. So we have seen the blue configuration. We have seen the customer entity here. Now let's look at the service layer. What happens basically when I do a get, right? When I do a get, see this is my Bloom filter bean actually, right? This bean, it calls this method might contain. So I'm sending the customer ID here, 100, 100 and 100 into whatever. See if it is not present or the way I told you, right? If it returns a 0 in any of the bits, then it will return customer definitely not present. Now you are not hitting the database. You are directly returning null. And say when it says that it may be present, then it hits the database. So this is the uh, implementation of your game. Now in case of save, what you would do is you would save the customer, and then you would also put it in the Bloom filter, any new customer. So that's important. So this is how the Bloom filter will work. So this is the service layer, and the API layer is straightforward. It will just directly call the service class. Let's try this out. I am sending a valid customer here. It returns the customer. And if I look into the application log here, it went here. It first checked whether it is a valid customer. Oh, sorry, not a the Bloom filter check basically. And it went to the database. Now let's try an invalid customer. It returned null as expected. But let's look at the flow. It didn't hit the database. That's the advantage here, right? So it directly went to customer definitely not present, return null. So this is the advantage of the Bloom filter that we get. So you're avoiding a lot of false from the database. So just a recap again, it's a probabilistic space efficient data structure. Why space efficient? Because you are using a bit array. You are not actually storing the customer ID. The customer ID is of 8 bytes or 10 bytes, right? If you multiply it into the millions, that would be a very big number. You might need GBs of storage. But in case of Bloom filter, you might just need 100 MBs or maybe 10-15 MBs based on the size. So that's the advantage. And then it returns two values. Either it is possibly present and definitely not present. If it is possibly present, it will go to the next layer. Here it is database, but it can be a cache also. So that's the advantage. And Bloom filter can have false positives, which I have explained like the case of 1%, right? The invalid customer IDs may still hit the database, but that percentage is very small if you give the correct values. Now let's look at the usages. Now what happens? The database query optimization, right? If you are sending invalid, first you go to the Bloom filter. It returns not present. If it is present, you hit the database or cache basically. Here it is cache penetration protection. Even your cache hits also is saved. See, in case of invalid request, in case of caches also, see, my customer ID is not present in database, so it won't be present in cache. Say Bloom filter is not present. User request, it goes to the cache. It will be a cache miss. If there is a cache miss, then it still hits the database. So your bots or your hackers or your attackers will always send the invalid key basically. It could be customer ID, anything. So here you are also saving the database in this way. Then there is web crawler URL filtering. If it is already visited or not. Then duplicate detection in editor streams where Kafka etc. uses this. Then distributed systems. Members check if an item exists in a large distributed set. So if there are multiple nodes, right, in distributed systems, and you want to check if the item is present or not, then checking in all nodes, it will take a lot of time. So you're reducing the network traffic and system load as well. Your Bloom filter can sit in at the top and then it can return if it is not present or not. This is the advantage of Bloom filter. I hope you would have enjoyed this lecture. Try to use it in your day-to-day work and your architecture. Thank you so much.